To other examples we can see. All right, so that's the one way of thinking about it. Now let's go to my game. Truth is, I go out and talk to other professors, and other professors don't talk about games, and I don't quite get yet what they do talk about. I mean, maybe you guys can tell me, how did you get the difference between for all and exists and for all? Did you think about it as an and or not circuit, or how did you explain this? Loops. Loops? For loops. So here we're going to loop over all B's, and here we're going to loop for all G's. Only, that's right. So then what do you write here? You can just put a specific G for a second. Yeah, specific G, right? Yeah, choose a G. Right. Yeah, so it does have this nested loop kind of feel to it, right? And I was imagining, I'm here, a branching program, right? Here, I'm branching out on all possible B's. And then here, I'm branching out on all possible G's, right? But this, because it's a for all, I need an and here. This has to be true for all of them, right? While here, there exists, so this is kind of like an or, right? People see it that way? People see it this kind of loopy way? Yeah. Let's go to the game way, right? And really, you can give me feedback of what works for you, right? Here, the game, right? So for this course, let's try the game method, all right? I like games. No, actually, it's a lie because I hate playing games. We talked about it just last class. I hate playing games. But here we go. The game is going to have two players, right? The guy who's trying to prove it is the blue one. The disprover is the red one, right? And we're gonna read the statement from left to right, right? Just like we have the nesting. And whenever I have to prove that there exists something, how do you prove something exists? The prover is going to produce it, construct it. It's going to be a constructive proof. Here's my thing, right? And how are we going to prove a for all? Well, if it's true for all of them, well, I could go through all of them, but that would take a long time, right? I'm really lazy here. So instead, we play a game in which I assume I have the worst evil adversary out there. And what is the worst adversary going to give me? Is the worst possible example, right? The adversary is trying to prove the statement is false. So the adversary will give me the for-alls, right? And then we see who wins by whether the statement's true, right? So you can imagine the game over here, right? We're trying to find, down here we're going to have loves BG, but we need this object and this object from somewhere, right? And where does it come from? Here, it needs to be true for all of them. So I guess the adversary decides which way to go, and when there exists one, then I get to choose which one to go. Right? The adversary is trying to make it false, right? So if it's false, then one of these is not, right? Let's think about proof by contradiction, right? If for all is not true, then there exists one that's not true, right? And if there exists one that's not true, then the adversary will tell me who that is, right? The counterexample. So here it's an and. So if this is not true, the adversary says for which one it's not true. And if now it's an or, so if it's true, one of them's true. And I say for which one it's true. Right? Everybody kind of following this game here? So here, let's play the game. Right? It's a for all. So the adversary is trying to prove that it's not true. Right? So the adversary is trying to prove that there exists a boy sits that for all girls he doesn't love her, right? So he says, no, it's not true. It's not true for Bob, right? And then, now it's my turn. I see the exists. I often think about me as the blue guy, right? You can, right? So, all I have to do, I know Bob, and I look down here and say, who does Bob love? Does Bob love anybody? Yeah, Bob loves Marilyn Monroe. So I say, I produce Marilyn Monroe, and Bob loves Marilyn Monroe, so I win the game, right? And if I can give you a strategy in which I always win, then the statement's true, right? So we could try to play the game again, right? He could say Bob, he could say John, right? And I say Mary, and then I win, right? And when do I win? I win when for everything he could say, for every move, right? When do I have a strategy that I'm going to win a game? I'm going second. I have a strategy when I know for whatever he does, I can do something to win. Right? That's what it means. For every there exists. All right, so now we switch them. Right? How does the game change? It changes that I got to go first. And is that good for me or bad for me? It's very bad, right? The order really matters, right? He says, ha, 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 you got to go first, right? So I have to produce one girl without knowing his boy, right? I come up with one girl. I say Marilyn Monroe. No, he can say, no, Marilyn Monroe isn't loved by John, right? So I lose the game, right? So this statement is false, right? And what do we need? In order for me to win this game, there needs to be a single girl that's loved by all boys. And that's just not the case here, right? So I'm going to lose this game. And but now if we change the world, we go to a different universe, a different day, now I can say Marilyn Monroe, and whatever he says, I'm going to win. Right? Why? Because there's this one girl that's loved by all boys. Everybody good? Right? And so this is another argument that George and I was having, actually. I was saying, oh, well, I want to have this function. And he was saying, no, that doesn't work. But then he wrote me back and said, well, actually, I do it in my second book. Well, then why did you tell me it was wrong? Right? All right, so here, I'm thinking about this proof is an algorithm where, right, if what's happening here? I come up with a girl, then the adversary gives me a boy, right? And then I have to say for an arbitrary boy, I have to prove that that boy loves Marilyn Monroe. Right? Somehow I have to prove an arbitrary boy loves Marilyn Monroe. And you know how you do that. Now here it's a little more complicated game. Right? The adversary gives me a B, and then I need to come up with an algorithm that takes his B and produces what? Produces a G. Right? My G is a function of his B. Right? So, and then I have to come up with the G, and I have to come up with the proof that we have love there, right? So, if you come up with Sam, I come up with Beth, different relationships. So, some people learned in 1090 or so where that proofs by contradiction are good. Sometimes I like them, but usually I find that they're just confusing things, right? People will prove this by contradiction. They'll say, if it's not true, then there exists the B for which it's not true. And then they say, well, let B be the object that is assumed not to exist. And then you prove that there's a contradiction. And, everybody following this? And then you prove it. But I like my method better because you're not proving the contradiction and then letting it, right? It still boils down to the same, right? Here we have the same. Let B be some object where did it come from? Well, it could come from the contradiction, or it could come from my adversary. It boils down to the same, right? So I like the game method more, but this is again showing there are other methods, and they really boil down to the same. You people, how are we doing? You doing okay? All right, right? Said play the game. All right, so now, if we're really going to be proving things, we want to be able to prove things like that. This, if A is true, then B is true, right? And everybody knows that this doesn't mean that A is true. It means if A is true, then B is true. What it means is it's not the case that A is true and B is false, right? We don't have causation or anything here. But how do you prove this? Well, you assume A is true, and you use that fact to prove B, right? So now what happens if A is this statement, right? Now, you've all taken 1090, so you have some sense of, well, I assume this, and now how do I use that in my proof? And, when I was looking at the proofs that people were doing in 1090, I wasn't getting in my heart how they were using it, right? They were following these rules that I didn't really understand, but, right, so let me tell you how I would use it, right? How I use the fact that this is true. Remember, the way I think about this statement is that it's a game. What's the game? Adversary gives me a boy, I give you a girl, and we check whether they love, right? So to prove that this is true, what do I have to do? I have to give you a strategy in which I'm going to win this game, right? Now the flip side is, let's assume we know it's true. If we assume it's true, then what do I have? I'm assuming I have a strategy in which I can win this game. So I can assume that I have an oracle out there. What is an oracle? Right? It's a burning bush on top of a mountain, and I can climb up there, and I can ask it questions. Right? And what does an oracle for a strategy, a game mean? Is whenever it's my turn, it'll tell me what to do. Right? So that's kind of what we're doing here. If A is true, then there's a strategy for this game. And what am I going to do with that? Well, the game, remember, the adversary is going to go first and give me some boy. And then what do I have to do? I have to come up with a girl. So what my oracle is going to do for me is, for any boy, it will give me a girl. Right? So I have this function that's going to help me. Right? Does that kind of make sense? Right? And how do I use it? Well, if I know this is true, whenever I have an arbitrary boy, I can say, let G be the girl that's assumed to exist from this statement. Right? I know that every boy has some girl, so my specific boy has some girl. Who is it? Right? So I'm trying to stick in these auxiliary functions, right? And what do these auxiliary functions do? It's a function from the boy to the girl, right? And what we're just saying, this is sort of saying the same. I claim that this says the same thing, right? It's this up here. It's saying for every move that the first guy goes, for every boy, then here's the girl that he loves. Yeah? Yeah. I didn't say anything about B. Right? B is blank here. I'm just saying, how do I use this? Well, that's all within here. All right? So I haven't said, this isn't anything about B. What is it saying? It's saying, if I know that this is true, then I know I have a strategy to win this game. And what is the strategy going to do for me? It's going to be an oracle in which, if the adversary gives me a boy, then I'm going to have a girl. Right? I'm assuming that I know for any boy you give me, I can find a girl for which the boy loves the girl. Right? So, yeah?
What is your A and
A is this, and B I haven't specified. Right? So we're not talking about B here at all. We're talking this is A. No. We're assuming A, and then we're proving B. I haven't told you what B is, but I'm telling you how to use A. Right? If I told you, hey, I'm an oracle and I can be an oracle for your game, then you can go out in the world confident that that you can win this game. Right? And how are you going to use that fact? You're going to use that fact is if you're bumbling along the world and suddenly some adversary comes out of the dark and gives you a boy. Right? The adversary gives you Sam. Then you can be confident that for every boy there exists a girl. Well, who's that girl? Oh, maybe it's Beth. Right? Then you walk down the world further, and out comes of the dark comes this Fred. Oh, well, you know every boy loves some girl. So who does Fred love? Fred loves Anne. Right? And what's this oracle doing for us? Right? It's this function from who does the adversary give me, right, to, right, the adversary is going to give me some boy. And if I have an oracle to tell me how to play the game, then the oracle is going to tell me what girl to come up with. Right? So this is a function from boys to girls. Right? And what does this statement here say? I claim that these two statements are equivalent. Right? And this is what George and I were talking about, is are these two sentences equivalent? And for me, they are, because what does this one say? This one says, for every boy that the adversary could give me, I have an oracle G. Right? In fact, let's do it first. I have an oracle G. I have an oracle G, such that what? Such that any boy the adversary gives me, my oracle will give me a girl that boy loves. Right? I'm here. What am I assuming here? This is my A. I'm assuming A. What does A give me? A gives me this function G prime. And what does that function G prime do for me? It says for any boy, I can plug in B, the boy, into the G prime, will give me a girl, and I can be assured that the boy loves the girl. Right? It's a very powerful statement. Right? Everybody got that? All right, we're good? Right? So, say those mean the same. Here I just sort of, people need to love and be loved, right? What does this say? This kind of says, I added this trying to struggle with free variables, right? What does this say? Well, which person needs to love and be loved, right? All people? Are we implying it for all, right? What that says for all. Jeff needs to be loved and loved, right? That's a constant, right? Jeff has this property, he needs to love and be loved, right? Now, it's assuming there exists, right? I don't know. It's hard. Free variables are hard, and I'm still struggling with them. So we're going to be thinking about free variables is it an arbitrary value? Is it a constant? Right? Anyway, that's all 1090 stuff that we're not doing 1090, but this is good practice for me in case I have to teach it again, right? Let's see. Negations, right? Everybody know how to do a negation, right? If there doesn't exist a boy, then if there doesn't exist a boy, then for all boys it's not true, right? And if it's not true for all, that was girls. If it is not true for all boys, then there exists a boy for which it's not true, right? And so you bubble it in, right? And you'll note, right, the exists is moving to the right. We're changing exists and for all, and we're changing equals to not equals, and we're switching roles, right, from trying to prove it's true to trying to prove it's false, right? We're switching the roles of this game. All right, here's another thing we want to say. For all boys, right, what's the negation of for all boys? there exists a boy, right? We're still talking about boys, all right? So we're still talking about the set of boys. So let's do another one here. Here we're saying for all x, there exists the y bigger than x, right? Now this is getting into weirder notation, right? Because the range of the y depends on the x, and that's kind of weirder. But people write this kind of stuff all the time, so you should know what it means, right? So how do we take the negation of this, right? We're going to have there exists an x, and we're going to have for all y, right? But now what do we do with this? Right? Do we say this? No. Why not? This is, you got to think, is this wrong? Right? Here I negated that. Should I be negating that? Yeah. Remember what we did before? We turned for all B in boys to there exists a B in boys, right? The domain boys didn't change. We were talking about boys, right? So here we're saying there exists a y that's bigger than x. We're talking about numbers that are bigger than x. So here we still want to talk about numbers that are bigger than x, right? We want to say for all y, before we said there exists a y bigger than x, now we want to say for all y bigger than x. This is not true. People kind of getting that? So this stuff is subtle. It's hard, but it's important. Are you getting it? Yeah? All right, good. All right, so now let's do some more examples. Right? How are we doing for time? Let's see. We got 22. Where do we go to 4 in this class? 4, 10, 4. So, half an hour. Good. I always need people to, I'm so bad at that kind of math. You always shout out. How much time we got left? We got a half an hour left. Any questions about what we're doing so far? Yeah?
On the previous slide.
Yeah. Yeah. Let's see. Where did it go? Here we get the negation of boys. Here we're doing negations.
Okay, so here it says y is equal to 2x. If it said like y is less than 2x, then we would change it to
Greater than equal to.
Okay.
Right? The point is, yes, when we bubble them in, we negate the predicate on the inside. Right? But this is, this is subtle. This is the range. And we don't negate the range. Just like here, oops. There's a button here which I hate. And the button says, go to the last slide. And then I'm on the last slide. Right, so here, right, we're not going from for all boys to there exists a girl. Right? We didn't do that. B's a girl. B's a boy. Right? So here, we don't go from there exists a y that's bigger than x. We're talking about things bigger than x. Y is smaller than x. We just don't care about. Right? All right. So